In the previous lecture, we have discussed about the concept related to the noise triangle, pre-emphasis and de-emphasis network, and that was about frequency modulation. Now, in this lecture, we will be beginning with chapter 4, which is radio receiver, which consists of AM, FM receivers, along with that SSB receivers. So we will begin with this particular chapter with parameters of radio receivers, which is to be understood. So we are going to study in detail the parameters of radio receivers such as selectivity, image frequency and its rejection, bandwidth improvement, sensitivity, dynamic range, and many other parameters we will be able to study for the radio receiver. Before starting with any of the parameter, I would like to explain the important block which you will be able to see in all the block diagrams of radio receivers, and that particular block is called as mixer. So to define the mixer is nothing but a non-linear device which is going to produce many frequencies at the output, and that particular frequencies sometimes we call it as harmonic frequencies, and apart from that it will be producing sum and difference frequencies at the output. Definitely the mixer is a non-linear device. It is going to mix the two signals, and for the radio receiver we are going to have two signals as the incoming radio frequency, that is incoming radio signal, which we are calling it as radio frequency signal RF, and another signal which will be locally generated, and that particular we are calling it as local oscillator signal. These two notations RF and LO we will be frequently using throughout the chapter. So RF is nothing but the received signal. Now we are talking about receiver. So first block will be the antenna, and received signal from the antenna we are calling it as radio frequency signal. It also noted with F1, local oscillator frequency noted with F2. This is the symbol for the mixer, which is going to produce many non-linear frequencies or the harmonic frequencies at the output, along with sum and difference frequency. And most of the time we will be using sum and difference frequency at the output, and that is why in this block it is shown F1 plus F2, which is sum of local oscillator and RF, and difference frequency is F1 minus F2, which is difference of RF and local oscillator frequency. Now to understand the concept of mixer, I have taken one example wherein my radio frequency, that is our input signal, will be, I am considering as 1 megahertz. Local oscillator frequency I am considering as 0.75 megahertz. Then mixer is going to mix this particular two frequency. At the output we will have F1 plus F2, we will have F1 minus F2, but most of the time radio receiver we are selecting difference frequency at the output, and that is why we will be able to see here the resulting signal is 0.25 megahertz, which is 1 megahertz minus 0.75 megahertz, that is RF minus LO, which will be equal to 0.25 megahertz, and this particular frequency is called as IF, which is called as intermediate frequency. Why it is called as intermediate? Because you can see the value of this frequency falls between RF and local oscillator frequency, and that is why this particular is called as intermediate frequency or the difference frequency. And this is the third notation which will be frequently used throughout the chapter. One is RF, which is called as incoming radio frequency. Second is called as local oscillator, which is internally generated, and the difference between that will be, it can be sum also, but for the radio receiver we are using difference, and that particular difference we are calling it as IF, and that is called as intermediate frequency, and followed by that we have intermediate frequency. Now if we plot the spectrum of whatever example which we have taken just now. So you can see F1 is having a frequency of 0.75 megahertz, F2 is having a frequency of 1 megahertz. So this is the two lines corresponding to two frequencies. Since this is frequency spectrum, x-axis will be frequency, y-axis will be any amplitude or a voltage or a power, anything can be there. But frequency spectrum may, if you remember, we used to show sine wave signal or any frequency component by a vertical line. That is why F1 and F2 are shown. The some frequency will be definitely greater than this, which will be 1 plus 0.75, which will be 1.75 megahertz, which will be on right hand side because right hand side is the higher frequency, and 1 minus 0.75, which will be 0.25, which is the lower frequency, which we are calling it as intermediate. Again, to highlight here, we are for the receivers, we are using the difference frequency. We are taking difference frequency from the mixer, and that is why this particular frequency is called as intermediate frequency. So with this background of the working of mixer, we will be beginning with the first parameter of the radio receiver, which is called as image frequency. And to understand the image frequency concept, the concept of mixer is very much required. So what is image frequency? Image means actually the replica. So image means any frequency other than selected radio frequency if allowed to enter into the receiver, and that will going to produce the cross products equal to IF. So image frequency means any frequency which is replica of selected radio frequency, and if that particular frequency is going to pass to our local oscillator, then that frequency will also produce same intermediate frequency as produced by our RF signal. You know how intermediate frequency comes? It comes from the RF and local oscillator frequency. Now image frequency is also one frequency which will produce same IF. And I'm going to take one example for understanding the image frequency concept. But once the image frequency is mixed, it cannot be filtered out or suppressed because it is going to produce same as that of our IF signal. So higher intermediate frequency should be selected to reduce the image frequency effect, and for that I will be taking this particular example. So in the figure 1, that is this particular figure, there is some message named as Hello John, which is coming at a frequency of 1560 kilohertz. I am taking this example to explain image frequency concept. So there is some message Hello John, which is coming at a frequency of 1560 kilohertz, and this is antenna received and that is given to a mixer. Now consider that mixer is having a local oscillator frequency of 1500 kilohertz, and we said that we are going to have a difference frequency at the output of mixer. So that intermediate frequency will be equal to incoming frequency minus local oscillator frequency, that is 1560 minus 1500, which will be equal to 60 kilohertz. So this Hello John message, this is our incoming RF signal, and this is what is our desired signal, which is to be passed through a mixer. Now consider second diagram. In the second diagram, there is a image signal. So I have written here image signal. The message of the image signal is different. That is Hello Bob, which is coming at a frequency of 1440 kilohertz. This frequency is 1560. This frequency is 1440. Local oscillator frequency will remain same, and that is equal to 1500 kilohertz. Now again output of the mixer will be difference of the local and incoming frequency. So 1500 minus 1400, which will again give us output as 60 kilohertz. And this is what is the image frequency. This Hello Bob is the image signal. This is not our desired signal, but still it is producing the intermediate frequency of 60 kilohertz. Hello John is our original information signal which is desired, and that is also producing a 60 kilohertz. So you see the image signal is coming at different frequency, information signal is coming at different frequency, but they both are producing same intermediate frequency at the output, and this is what is called as image frequency. So that is what we define, that image frequency will also produce same intermediate frequency as your original information signal is producing. And that is why we have made a statement that once image frequency is mixed up, it cannot be further removed. So here you can see the image frequency will be producing a similar graph of that of the wanted signal, because they both are separated by a same distance, 60 kilohertz, 60 kilohertz in the previous example. This is another example wherein you can see your RF is 800 kilohertz, local oscillator 1255 kilohertz. If you subtract, then your IF will be 455. There is another signal at image which is 1710 kilohertz. Local oscillator is still 1255. The output will be still 455 kilohertz. So you can see RF is different, image is different, but intermediate frequency is same. So these two examples are taken to understand the concept of image frequency. So image frequency, you can see it is separated by the same amount as your RF is separated. So this is your local oscillator frequency. RF is separated by IF, and image is also separated by IF. That is why it is IF. So this is the spectrum where RF and image both are shown, and they both will look similar. So for a radio receiver to produce a cross product equal to IF, it must be displaced from local oscillator frequency by the value of IF. And that is why the image frequency with high side injection can be calculated. What do you mean by high side injection? When your incoming frequency is below the local oscillator frequency, then image frequency can be calculated as FRF plus 2FIF. RF is your incoming frequency, IF is the intermediate frequency. With low side injection, your selected RF is above the low side injection. The selected RF is above the local oscillator frequency, and therefore the image can be calculated as FRF minus 2IF. So image frequency is going to produce the same result as that of your original, and that is why we need to design some circuit which is called as pre-selector, which will have the image frequency rejection ratio. So what is the definition of IFRR? It is the numerical measure of the ability of a pre-selector to reject the image frequency, and for a single tune pre-selector, ratio of its gain and desired RF is the image frequency. So IFRR is equal to under root of 1 plus Q square into rho square, where rho is calculated by using this formula and Q is nothing but the quality factor of a pre-selector. So it is very important that image frequency should be rejected at the receiver at the starting end by the pre-selector only. Otherwise, if the image frequency is mixed up, it is very difficult to separate at the receiver, because it is producing the same effect as that of the original RF. And for that, we have taken the two examples to explain here the concept of image frequency. In the next lecture, we will be continuing with another parameters of the radio.